NAP packs, or Kubernetes Native Application Packs, provides the simplicity of development and deployment that developers like about Cloud Foundry, with the power and the flexibility and the enterprise scale that is provided by the Kubernetes platform. Today, our solution architect, Champ, takes his developers' applications and deploys them on application servers such as WebSphere, where he has complete control over the run environment for that application. As he moves to cloud native, he needs to understand how to run 12-factor applications and make a larger number of decisions about how those applications are deployed and run in his environment. And our developer Jane needs to learn how to build microservices, which may mean learning a number of new frameworks and technologies, as well as navigating through the various options for how to build, package, deploy, and carry out monitoring and logging for her new microservice applications. NapPacks allows Champ to define his own opinionated platform, which uses a base set of best practices provided by IBM, but also allows Champ to customize that opinionated platform based on his own requirements, such as how authentication and logging is carried out. On top of that, NapPacks enables Champ to build a set of pre-configured application stacks that perfectly matches his opinionated platform, effectively providing a platform as a service layer to Jane. And Jane can now use that platform as a service layer to rapidly build and deploy microservers that implements her business logic. For this to happen, Champ takes those stacks which are designed to work with his opinionated platform and provides them so that Jane can use them. Jane starts by using the NAP CLI to discover the project types that Champ has configured that she is able to use. Once she has discovered the available stacks that she can use, she can create a project from that stack using NAP dev init. This gives her a skeleton for her app, which she can use to build her business logic, as well as providing support for IDEs so that she can build and incrementally develop her application using the latest version of Champ stack. Once Jane is happy with her changes, she can save her project and then commit them to source control such as Git. Let's see how that works in practice. Jane first installs the CLI using the standard OS tools for install. This then provides her with everything she needs to develop and build her applications. Using the repository she has configured, she can see a list of all the projects that she can create, and she can create a project, in this case Java microprofile based on OpenLiberty. She can then open that in her favorite IDE, in this case Visual Studio Code. Inside her project, she just has a skeleton of some basic source files for her application, in this case a Hello World application that runs on the root URL. She has syntax highlighting and code completion as she would normally expect in any IDE, and then she can run it inside a development environment that has the application running live in her browser. In her browser she can see that Hello World is reported, and she can also make code changes to her application and save those and see those updated in the browser in real time in an incremental development environment. She also gets metrics and health checks and OpenAPI support added for free because these are configured inside Champ's stack rather than inside Jane's application. And this means that all of the capabilities that Champ wants to have in his platform, such as monitoring, is included out of the box, and Jane can see this in her local development environment. Once Jane is happy with her changes, she can create a Git project in which to store her application. As well as wanting to store her application, she wants to be able to build it, so she sets up a Git hook that will dynamically build the application on code changes, and she can do this directly through the NAP CLI. Once the Git hook is created, any code change being made to her project will dynamically drive a build pipeline to build it. And that build pipeline takes both Jane's application and the latest version of Champ's stack and combine those and then deploys them to Champ's platform. Jane saves her project to Git, as she would normally, and these code changes can be seen in the Git repository. The moment those code changes are made, the build pipeline is triggered, and Jane can track that build pipeline in the build pipeline dashboard. This shows the progress through the build pipeline, which is building the application into a Docker image and then deploying it to the platform. When it completes, the Docker image can be seen in the Docker repository as a new entry, and visiting the platform will show that the application is running just as it was on her laptop, including the metrics, the health checks, and the Open API support that she had previously. NatPaks makes it possible for developers to very quickly build cloud-native applications using best practices and following the guidance and the requirements of their platform architect.